Afternoon. The Committee on Science, Space, and Technology will come to order. Without objection, the chair is authorized to declare recesses of the committee at any time. Welcome to today's hearing entitled An Overview of the Budget Proposal for the National Science Foundation for Fiscal Year 2017. I now recognize myself for 5 minutes for an opening statement. As we've discussed before the hearing, we may be called for votes shortly, so our apologies. But we'll try and get in as much as we can before that. I would first like to thank our witnesses for appearing today to discuss the National Science Foundation's fiscal year 2017 budget request and other foundation issues. The 2017 discretionary budget request for NSF totals $7.56 billion, an increase of approximately $100 million or 1.3% over the fiscal year 2016 enacted level. NSF is the primary source of federal funding for non-medical basic research and supports through 12,000 competitive grants a year over 377,000 scientists, engineers, educators, and students across the country. Excuse me. I'm recovering from a little cold. Sorry. Actually, I may just yield to my colleague, and I will see. So sorry for that. Thank you.
All right, as the chairwoman recuperates there, I wanted to thank the chairwoman and the chair of the committee for holding this hearing. Welcome, Dr. Cordova and Dr. Arvizu. The NSF is central to our nation's leadership in science and technology. And I think it's important that more people understand the critical role that NSF plays. NSF supports fundamental research across all fields of science and engineering. And that research serves as a foundation on which our knowledge of our own world and worlds beyond it is expanded, our innovation economy is built, and our quality of life is improved. Over time, NSF has become the primary source of support for basic research across many fields, including the biological sciences, the social and behavioral sciences, and computer science. The fiscal year 2017 budget request for NSF includes new mandatory budget authority. I like to think of myself as an optimist, but it's hard to imagine a scenario in which there is agreement anytime soon on new mandatory funding. I wish, therefore, the administration had found additional support in the discretionary budget for the foundation. I hope that my colleagues on the Appropriations Committee, in making their own very difficult trade-offs, will once again find a way to provide an increase for NSF. Having said that, I'd like to highlight a few programs and initiatives in the budget that stand out to me. I see that NSF is not proposing any major new cross-agency research initiatives in fiscal year 17. However, the ongoing initiatives in risk and resilience, innovations at the nexus of food, energy, and water systems, known as INFUSE, the understanding the brain, the secure and trustworthy cyberspace, and many other that are in there, remain in the budget, are essential investments. And I want to commend NSF for continuing to break down disciplinary barriers to address grand challenges for science and technology and for our nation. In particular, I'm glad to see the investments being made in the Innovation Core program and in the Smart and Connected Communities initiative. As a leading proponent of the I-Core program from when NSF first created it, it's great to see that it's been a great success. With minimal NSF educational funding, many startups coming out of I-Core trained teams have already received venture capital funding. And I look forward to more innovation and jobs coming from graduates of the program. In addition, the White House announced at the August demo day the partnerships that the NSF I-Corps program created with several new agency partners, including DHS and the Defense Department. This demonstrates that NSF's I-Corps program also works within the government. I hope this will help other agencies see what NSF has long known, that the I-Corps model dramatically helps in translating research into new technology and new jobs. Similarly, the smart and connected communities, we are seeing more and more impact that connected devices have on our lives, as well as the promise they hold for the future. The early examples that we have seen in transportation with connected and autonomous vehicles are just a small piece of what could be possible when we adopt a smart cities approach to integrating technology into traditionally disconnected devices. Cross-cutting research is needed to drive these changes, and I'm glad the NSF is taking a leadership role here. With respect to the Education and Human Resources Directorate, I'm interested in the systems approach that Dr. Cordova is taking to broaden participation in STEM in the Includes initiative. So I look forward to discussion and progress reports on that effort. I'm especially pleased to see the increase for the Cybersecurity Scholarship for Service program. The shortage of a skilled cybersecurity workforce in both government and the private sector is well documented and has significant consequences for national and economic security. However, I do have concerns about the proposed discretionary budget cuts to the informal STEM learning research program and the STEM-C partnerships program. So I look forward to an explanation of the status of those programs. Finally, I anticipate there'll be some discussion today about prioritizing some fields of science over others. So let me conclude by quoting from our colleague, Chairman Culberson, Chairman of the Commerce, Justice, and Science Subcommittee of Appropriations. Following his own hearing last week with Dr. Cordova, in which he stated clearly he does not want to appropriate by director at NSF. He said, quote, "I think we should let NSF pick the most promising areas and give the agency the flexibility to pursue them." I strongly agree with Mr. Culberson on those points. Thank you again, and I look forward to hearing the testimony.
Thank you, Mr. Lipinski, and given my limited, what this cold is doing to me, I'm going to yield now and recognize the chairman of the full committee, Mr. Smith.
Thank you, Madam Chair, and let me welcome Dr. Cordova and Dr. Arvizu here as well. In the interest of time, because we're expecting votes to be called in 5 minutes, I'm going to ask unanimous consent that my opening statement be made a part of the record. I simply want to add also that I've just had a good conversation with Dr. Cordova in my office, and how shall we say this euphemistically? We've exchanged views on some of the questions that I intended to ask today, all except one. And perhaps if she could address that in her opening statement, then I will not need to ask questions later on. And that is, how is the National Science Foundation implementing the STEM Act and prioritizing computer science in its STEM education grants? I know she's familiar with that bill that passed, and I want to thank her for support of that legislation. I'm just curious how National Science Foundation is implementing that piece of legislation. And with that, I'll yield back in hopes that we can get underway before the votes come. Thank you, Madam Chair.
Thank you, Mr. Chairman. And now I'll introduce our witnesses. See how far I can get through. Our first witness today is the Honorable Francis Cordova, Director of the National Science Foundation. Dr. Cordova was sworn in as Director in March 2014. She is President Emerita of Purdue University, where she served as President from 2007 to 2012. From 1993 to 96, Cordova was Chief Scientist at NASA, and she is a recipient of NASA's highest honor, the Distinguished Service Medal. She has a BA from Stanford University and a PhD in physics from the California Institute of Technology. The Honorable Dan Arvizu, our second witness, is the chairman of the National Science Board. In 2004, he was appointed by President George W. Bush for a 6-year term on the National Science Board. In 2010, he was reappointed to a second 6-year term. In 2012, he was elected as chairman of the NSB. He is the Director Emeritus of the Department of Energy's National Renewable Energy Laboratory, and he has a Bachelor of Science degree in Mechanical Engineering from New Mexico State University and a Master of Science degree and PhD in Mechanical Engineering from Stanford. I now recognize first I will enter my statement for the record also. My apologies, but we'll move through here. And I now recognize Dr. Cordova for 5 minutes to present her testimony.
Thank you. Chairman Smith, Chairwoman Comstock, Ranking Member Lipinski, Congresswoman Bonamici, Congresswoman Esty. Good afternoon. In my written testimony, I've addressed specific aspects of our FY 2017 budget request. NSF believes that this budget would substantially further the progress of science. We like to say that NSF is where discoveries begin. Increasing the breadth and depth of knowledge that can come from specific exploration and discovery is a goal of NSF. The past year has been one of notable scientific discoveries from every domain supported by NSF. I only have time in my opening remarks to mention one such discovery. Just last month, scientists from the NSF-supported Laser Interferometer Gravitational Wave Observatory announced the first direct detection of a gravitational wave, a landmark discovery that reflects decades of investment and that opens a new window on the universe. I'd like to thank the committee for holding a hearing on the topic of this discovery, and we appreciate Congress's recognition and support for this great experiment. We also like to say that NSF is where discoverers begin. Many times, scientists and engineers tell us that their first grant was from NSF. Other federal agencies tell us that they often fund projects which were first prototyped by NSF to advance an original basic finding into application. NOAA depends on NSF's funded NCAR for reliable numerical weather prediction. Just last week, NCAR mapped the expected transmission of the Zika virus in the United States, information that will be useful to NIH, CDC, and of course, the public. NASA missions sometimes have their genesis in discoveries first made with ground-based observations funded by the NSF. I think of exoplanets, for example. Many Nobel Prize winners were funded by NSF early in their careers. Some, like the former Secretary of Energy Steve Chu and the founders of Google, while they were graduate students. Thus, increasing the STEM workforce, ensuring that it is ready to take on the challenges of our increasingly technological society, and making STEM careers accessible to the wealth of talent that this nation has to offer are also goals of NSF in its new Includes initiative. NSF's budget, after adjusting for inflation, has increased very little since 2003, with an annual growth rate of less than 1% since then. In fact, since 2010, we've actually seen a slight decline in research funding in constant dollars. Yet in the same time period, the number of proposals has dramatically increased. The result is that the fraction of proposals that we can fund has decreased significantly. The funding rate was 30% in FY 2000 and is just over 20% now. Of great concern to us is that the situation is more challenging for people who haven't previously received an NSF award, including young investigators. For them, the funding rate has gone from 21% in FY 2000 to 16% today. And for major center programs like the Science and Technology Centers, the figures also highlight the intense competition for funding. Fewer than 2% of the applications we receive can be funded. So imagine all the potential discovery science that is left unfunded. In fact, the amount of additional money it would take to fund all proposals rated very good to excellent in any given year is $4 billion. $4 billion of worthy research left on the cutting room floor every year. When a young investigator submits a proposal and it is rated excellent but not funded, it can be an invitation to leave the field of science. We are not only losing discoveries, we're losing discoverers. Thus, our FY17 budget request starts to correct this situation in order to accelerate the progress of U.S. science. And accelerate it we must. The U.S. currently ranks number 10 among all countries in research intensity. That is, the ratio of R&D expended versus GDP. If we're to retain our global leadership position, if we're to fully utilize the talent inherent in our citizens, if we're to continue to make a difference to our economy and our nation's security, we need to accelerate our investment. With an increase of $400 million requested in FY17, we can't solve the $4 billion deficit that we have in our funding rate, but we can make a start. We would use the funds to focus on early investigators within several years of their PhD. We can give them an all-important start on careers in science and engineering. I'd also like to take a moment to note that in the last year, NSF has made great progress in improving our efforts to refine and explain our programs and processes in a transparent and accountable manner. I'd be happy to discuss our efforts further. With your continued support, NSF looks forward to supporting more discoverers and making more transformative discoveries. This concludes my testimony, Madam Chairwoman, and I'll be pleased to answer any questions. Thank you.
Thank you. Chairman Smith and Chairwoman Comstock, Ranking Member Lipinski, and other members of the subcommittee. I appreciate the opportunity to speak with you in support of the National Science Foundation's FY17 request. As NSF's governing body, one of the most important functions of the National Science Board is to identify future opportunities for the progress of science in the nation. NSB wants to ensure that we continue to support scientific and economic advances like those associated with NSF's leadership in developing the internet in 1980s and 1990s, and more recently with nanotechnology. For the U.S. to remain the world leader in research and innovation, NSF must continue to push the frontiers of science, investing wisely without fear of failure. Seizing future opportunities requires a STEM-capable U.S. workforce and the same unwavering long-term commitment to scientific discovery that the U.S. has shown in the past half-century. The recent announcement by LIGO, for example, was only possible because of decades of work by the scientific community, NSF, Congress, and several administrations, along with over $1 billion in unflinching federal support. There are other such big scientific opportunities to pursue. The question is whether the U.S. is committed to leading the way. Information and computational science offer one such emerging opportunity. Advances in machine learning have combined with big data to give us an entirely new tool set, creating areas of research and ability to solve problems that have long defied solution. Recently, neural networks and reinforcement learning, which mimic human decision-making, enabled Google's AlphaGo program to beat a legendary Go player 4-1. The impact of machine learning are foreshadowed by South Korea's response, which is an $860+ million artificial intelligence research program. This is in partnership with Samsung and LG and Hyundai, going far beyond gaming and computer science. In the next decade, big data and empirical modeling will transform science, much like calculus revolutionized physics and computers remade engineering. These tools will let researchers tackle heretofore elusive problems, including questions in the social, behavioral, and economic sciences that are among our hardest to crack. In the near future, we will be able to run simulations and make predictions about these complex systems. Let's consider how these tools are already transforming my own area of research, the electric power sector. Our electricity system is rigid, aging, and no longer able to meet our future needs. Fortunately, technology advances are providing the tools necessary to move beyond electricity as a commodity and into delivering services. This requires new investment in research to enable two-way power flow, new power electronics, a myriad of sensors and control points, new systems architectures built on layers of models and real-time feedback, simulations, and predictions. Harnessing this complexity will make our future electric system reliable, secure, clean, and affordable. Predictable and increased investments in research is needed to capture the benefits of massive data acquisition, empirical modeling, data analytics, real-time feedback, and controls. As my written testimony details, NSF's FY17 budget lays important groundwork to seize these opportunities. Now, having highlighted these opportunities, I now wish to call your attention to a significant near-term risk. NSF's ability to accomplish its mission starts with the health of its workforce and the organization. And our staff and critical infrastructure that they rely on are supported by the agency's Operation and Awards Management account. And recently, the AOAM account has been about 4% of the overall budget, even as the workload has increased significantly. In my 12 years on the board, NSB chairs have consistently testified that the account is under-resourced. I fear that the consequences of this shortfall will soon be evident. In FY17, NSB strongly supports full funding for the AOAM account. My testimony in highlighting both opportunities and risks underscores the seriousness with which the board takes its responsibilities to provide strong governance of taxpayers' investments. In my written remarks, you'll find additional details on these activities. Just over 65 years ago, James Conant, the first chair of the National Science Board, portrayed NSF as a bold new experiment. Noting the need for continued vision, patience, and sustained investment, he wrote, "No one should expect to be able to assess in a short interval of time the value of the money spent on scientific investigations. Even in the field of applied science, research is in the nature of the long-term investment." As I conclude my final term on the board, I am more convinced than ever that our long-term national investment in fundamental science is essential to our future health, security, and prosperity. My colleagues and I thank you for your support of this bold but essential quest for advancing the endless frontier. Thank you, and I look forward to your questions.
Thank you. And I now recognize myself for 5 minutes for questions. Dr. Cordova, NSF's budget request calls for $70 million for the Cyber Core Scholarship for Service program, which that's certainly something this committee has spent a lot of time on cyber, so we appreciate that. And it's to recruit and train the next generation of information security professionals. How many new cybersecurity professionals will this investment be able to train? And how does NSF work with industry to understand their cyber workforce needs and to make sure we can get people to come into this field knowing, what the career path will be? Maybe, we've heard about delays in getting security clearances on things. How do you work through all that, and how will this money, what do you expect we'll see?
Thank you, Chairwoman Comstock. I don't know all the details, and so we'll get back to you on some of them. But I do know that with the $20 million augmentation, we're going to especially focus on what I like to think of as a reserve corps, that the people that go through the Cyber Core program, and we're working closely with universities on providing a really quality curriculum so that they are well trained. And a lot of very prominent research universities, universities in general, have stepped up to this challenge and are doing so. We want to make sure that the alumni of the program and the people who do scholarship for service after they've graduated then can be used as a resource in following years to come back and engage as they're needed on security matters. And that means a different level of continuous training. It's the same as if you were a doctor and you were continuously training, or a legal professional. And so that's really the emphasis of the new $20 million. As far as the number of students currently being trained, I know we are matched so much by the private sector and by universities themselves who are very interested in providing this curriculum that it is, I just don't have a number that I can share with you. It's a big partnership, and it's really, really growing. There's like a tidal wave of people coming into computer science in general.
Also, I'd like to ask you about STEM education, which we've obviously been funding. And actually, earlier this afternoon, we were working on some of those issues with this committee and with my colleague, Congresswoman Esty, and others in the committee. So, every year we are trying to place a larger emphasis on the subject, and, we still hear the frustrating statistics that we're falling behind worldwide. What have we learned from previous investments in STEM about what is really working and advancing? Is it getting kids at a younger age? How do we, keep the continuum going? What are the things that we are finding are, most helpful?
That's That's a very big question. Would you mind if I just started with the Chairman Smith's question with responding to that, because that leads us right into your question with the STEM Education Act of 2015. That added computer science to the definition of STEM, so this ties to your previous question. We're implementing the legislation by ensuring that our STEM education programs are open to all fields of STEM, including computer science. In addition, we've included some new goals in FY 2017, including computer science for all, which partners with the Department of Education. I visited with the Secretary of Education about this last week, and the private sector to ensure that all students in the nation have access to computer science education. So, so that is, I hope, Chairman Smith, that is a partial response to your question. On the larger question of what we're learning, NSF is always engaged in evaluation and assessment of its programs, and that applies as well to our STEM education programs. In fact, you will see a request in the FY17 budget for more money for evaluation and assessment and more money for core research in STEM learning, because we do want to learn from what we're investing in. The types of things, and a much longer response is deserved, but the types of things we're learning have to do with institutional commitment. They have to do with hands-on learning and ensuring that every student has an opportunity for that. They have to do with community participation and engaging in partnerships that go beyond the school, involving parents. They have a lot to do with teacher training. That's just absolutely essential. And having 2 teachers in my own family, 3 if I count my spouse, that I believe that continually upping the skills and teacher training, especially for a new computer age, is very, very important. So all of these, we then we take what we learned and we implement new programs that make use of that learning. So some of the questions that I know Mr. Lipinski alluded to that we'll get to later have to do with programs that perhaps we have that look on the ledger like they've gone down in funding or have stayed the same. Actually, what we've learned from that program or others have caused us to institute new programs to make use of that knowledge. And so that's how NSF is progressing in utilizing what it's learning in education.
Okay, thank you very much, and I now yield to Mr. Lipinski.
Thank you. I want to start out by just mentioning, I know that Dr. Arvizu had mentioned social behavioral sciences and economics in the context of big data. So I don't want to let a hearing go by without me emphasizing the importance of SBE. I'm glad that you did that, and I will leave my question maybe for the record on that, but I think always important to point out the importance of SBE and the critical questions that it can help us address. Dr. Cordova, I'm interested in the Smart and Connected Communities Initiative. As across our country, so-called smart cities are investing in technology to address challenges like reducing traffic congestion, fighting crime, and fostering economic growth. In 2015, the White House announced a new Smart Cities initiative to invest in federal research and technology collaborations to help more cities pursue implementation of Internet of Things and smart cities technologies. And last month's PCAST report on technology and the future of cities helped to underscore the value of this research. I understand that NSF has long supported fundamental research that underlies smart and connected communities. Can you talk further about some of this research and about NSF's contribution to the National Smart Cities Initiative?
We are doing a lot of work, especially in computer science, but also engineering on smart and connected cities and simulation and modeling. Some of the examples that Dr. Arvizu mentioned pertain in the area of energy efficiency. We actually call this initiative Smart communities because in our view it's larger than a city. It extends to regions and they're all very different. And so this is truly a cross-disciplinary activity that will involve us all in looking at things like transportation and communications, definitely security, and our risk and resilience initiative also applies here and is connected with smart and connected cities for how they become resilient against risks like, say, Hurricane Sandy and so forth. And so we are engaging the private sector in this. It's a very popular initiative, and I think especially with the tools that that computing offers us in doing modeling and optimizing what we already know, we can make a lot of headway. And we can also identify weaknesses in the system where we don't respond well to crises, whether it's, traffic crises, police crises. And again, this is a place where social science also comes into the picture in smart and connected communities, that we must take all the data that we are getting and ask our social scientists how to evaluate where we can make better inroads. And maybe Dr. Arvizu would like to.
Yeah, if I can just add to that, I think excellent response by Director Cordova. Obviously, you mentioned the Infuse program, which is at the nexus of several of the infrastructures that go along with energy, but energy and water and food. These are areas where these research capabilities actually can be more pronounced in terms of impact for our communities and for our cities to capture efficiencies that otherwise would go untapped.
Thank you. Yep. In my remaining time, I just wanted to ask about the Advancing Informal STEM Education funding. Informal STEM ed is something that I believe is very important. It's the main source of funding for science museums and other informal providers to innovate, develop, and test new models for informal STEM ed through all ages and all mediums. So I'm concerned about the funding cut. Is there any particular part of the informal STEM ed portfolio that you propose to scale back or eliminate in fiscal year 17?
No, on the contrary, I too, Mr. Lipinski, am very committed, as is our agency, to advanced informal STEM learning. Our FY16 estimate was $62.5 million, and so is our FY17 request. So we're not proposing to cut back at all.
Now, well, I guess we will see what happens because of the issue of the mandatory
right.
funding, which we don't really believe.
You are right to note that $7.5 million of the FY17 request is on the mandatory side of the ledger, but we view our budget as a total ensemble of $500 million that we think is necessary to make further progress in science and engineering. In fact, it's essential. And so we don't think of it as being stovepiped into one or the other, discretionary or mandatory. So when we make the request, it is with respect to $500 million request augmentation for this next fiscal year.
Okay, I understand your commitment. I just want to make sure that I raise that issue.
Yes, thank you.
Thank you. I'll yield back.
Thank you, and I now recognize Mr. Molinar for 5 minutes.
Thank you, Madam Chair. Dr. Cordova, thank you for being here. Dr. Arvizu. Question for you, Dr. Cordova. In your budget request for NSF requests $512 million for clean energy research and development, and my understanding is that's about a 38% increase. And I guess two questions would be: are you encouraging collaboration between the appropriate offices within the NSF and the DOE? And how do you make sure that there's no duplication of funding with Department of Energy Office of Science when it comes to these kinds of projects?
Mm-hmm. Well, thank you for your question. In fact, I'll be with them this evening with the Department of Energy. We work very closely with the Department of Energy, and my colleague here, Dr. Arvizu, until very recently headed one of the DOE laboratories, and this is his specialty, is on clean energy. We're very pleased to be working as in an interagency sense on this very important initiative. Where NSF comes in is on the very basic research on materials, for example, for rechargeable batteries, on floating wind turbines would be another example, on solar fuels, economical generation of hydrogen from water rather than methane, and on the new combination of organic and inorganic materials and what progress we can make with those. But if you'll allow Dr. Arvizu to comment, because this is his field.
Yes, thank you, Dr. Cordova. And I think, as Dr. Cordova has already suggested, there's close coupling with the Department of Energy, Office of Science, and even the applied offices. The kind of the good news and bad news about energy research is it's target rich. There's a lot of things that can be done, and where I think the mission agencies, the Department of Energy, is very much focused on applications and how you take those essentially to the marketplace more quickly. There is plenty of room for revolutionary work that goes on at the fundamental level. Office of Science is focused on high energy physics, basic energy research which relates to biology. The opportunity to do some really revolutionary, high risk, high reward sorts of outcomes really are not funded so much in the Department of Energy, and I think it's left to our tremendous capabilities within the university community, within other research labs, to actually offer ways in which we can really change the trajectory and move the needle on new revolutionary outcomes that I think you could not do within the national programs of the Department of Energy.
And if I could ask you both also, how is the private sector involved in that? Can the private sector apply for grants in this area?
What would you like to start?
So
We do work in parallel with the private sector. We certainly, well, one thing we fund is SBIR grants, okay, and a number of those small business innovative research grants, and so some of those are focused in this area. We, in partnership with private, we fund engineering research centers, ERCs. We have quite a number of those, and a few of those are specifically looking at clean energy, either materials or applications of some kind. And there will be partners from the private sector that are also funding that. It's one of the requirements of those engineering research centers that they have industry partnerships.
yes, and I think, you know, there's a wide spectrum of work that goes on that relates to energy and all kinds of forms of energy. And what we find is that the private sector primarily likes to work very close to the application and development side. So in that respect, that's really more of the purview of the Department of Energy, where they have many multiple partnerships requiring 50-50 cost share. In most cases, if it's more fundamental work even for them, they require less cost share from the private sector. Rarely does the private sector work in some of these areas, I think, that the National Science Foundation works in, although they do, in fact, have great opportunity and applications, again, depending on the nature of the technology. If it's software, if it's architectures, that they're more likely to do. But things that require larger commitments for longer term, higher risk, you find that the research labs in the private sector don't nearly address that part of the spectrum nearly as well as the Science Foundation does.
Okay. Thank you. Thank you, Madam Chair.
Thank you, and I now recognize Mrs. Estee for 5 minutes.
Thank you, Madam Chairwoman and Ranking Member Lipinski, for holding today's hearings. To Dr. Cordova and Dr. Arvizu, thank you so much for joining us. We've already discussed some of the issues I was going to flag, so I'm going to jump in, Dr. Cordova, with you, as we've discussed at length on STEM education. Could you talk a little bit about the scalability elements? You referenced just a few minutes ago how the National Science Foundation is trying to has done a lot of research on what works and what doesn't, but clearly one of those issues is not only what is effective, but how do we scale up? Could you talk about what the agency is doing on that issue.
Yeah, well, thank you, because that is one of the most important challenges that faces us, especially in our broadening participation initiatives. And by that, I mean, how do we include more women, underrepresented minorities, the disabled, in this great field that all of us at NSF and our board loves, and wish everybody could have the opportunity to learn more about science and engineering and ask themselves if I too could become a scientist. So that is really the basis that, I mean, and you just really pinpointed what is the essential element of our Includes initiative. So when I came to the agency and I saw, two years ago now, celebrate my anniversary on the last day of this month, I saw the fine programs that we're doing in broadening participation programs like the Ellis AMP program for minority scholars, like the advanced program for women at the universities, and so many more. All of them seemed very targeted to a specific group. They seemed localized. They didn't scale up, as you put it. And so the challenge, if we're going to really move the needle, is how do we do the scaling? There's now business manufacturing, it depends on it, right? You spend $1 million developing a widget, and then you want to pay just 10 cents for every next copy of it. All right. Well, we're not in the social economic challenges that we face. We're not very good at scaling up best practices. We don't take everything that we've learned and examine it and say, how can others utilize it? How do I communicate it? How do I engage others in using those models and adapting them for their particular region? And so we've put out a call now, just as of the last 2 or 3 weeks, on our Includes initiative, which is, whose intention is to bring more people into science and engineering, especially those who have not been included. And the focus of this is to fund proposals that are truly innovative in a scaling sense, that take the best of what we've learned and translate it to a larger environment and do some innovative experiments. So we're going to fund a lot of things, maybe at first go, 40 different pilot programs, see what works, and then we're going to down select to just a handful of the ones that seem like they've got a good goal, good metrics to get there, and that they really can make a difference and be replicated, and fund those at a much higher amount. So that is our intention with this, but we're on it. We too care about this scaling program challenge very much.
Well, I want to thank you for that. And you and I have discussed this at length. And I just have to note, just 10 days ago, I was in my district. I've gone to a lot of coding events, shared passion for including girls and children of color in these initiatives. And I went to one 10 days ago in my district at a hackathon. And it engaged young girls, and this was 3rd grade to 8th grade, in which they were paired with social service organizations in their community for a full day. And they learned about the homeless shelter, the animal shelter, the food bank, and they met actually with executive directors to understand the mission of these organizations, designed an app in one day to promote these businesses. And it's some of the research that MIT frankly found when they took their CS class and broadened it to have the objective be develop something that's socially relevant and important. And so I think having gone to so many of these, as I know you have, really saw a tremendous difference in seeing students being asked to engage on issues they care about and to learn about them as if they're co-equals with organizations and people in their own community and see themselves as being part of those practical problem solvers. So I think we need to make sure we're pushing to lower grade levels and encouraging those who have not been included to say, you can help address issues in your own community. And I think oftentimes we start too high up and only look at the postdocs and even the undergrad levels. And if we don't get kids in the door, by the time they're in 8th grade, they're generally never get in. So again, thank you for your work, both of you. Appreciate it very much. Thank you, and I yield back.
Thank you. And I now recognize Mr. Westerman for 5 minutes.
Thank you, Madam Chair. Dr. Cordova, Dr. Arvizu, thank you for being here today. Sounds like we just have votes. I just wanted to follow up, Dr. Arvizu, with a comment from the gentleman from Michigan, or question. In talking about renewable energy research, Secretary Moniz was here earlier today, and in all the discussions, I've not heard any talk about this vast resource of biomass that we have here in our country. We had 10 million acres of forest land burned last year. If you go through all the conversions and calculations and estimates per acre, you come up with the equivalent on an energy basis of about 26 billion gallons of gasoline that went up in flames on just on our federal lands. That doesn't count all the other biomass that we have. So my question is, why aren't we focusing more on utilizing those biomass resources versus algae or corn ethanol or other activities to research and find better ways to use biomass and a drop-in liquid fuel?
That's a great question, sir, and I think I'm a big fan of also using all of our renewable resources, including biomass, especially those that we consider waste streams, or things that are kind of left over after we cultivate either ag or other types of crops. And I think there is still a lot of work to be done. I think one of the concerns that I believe we have is we have kind of an unequal approach to the way in which we fund basic research across the entire spectrum. So I think there is room for that. Now being a former DOE person as opposed to a current DOE person, my own personal opinions about that are that there is a great deal of opportunity there to do continued research on taking essentially carbons, oxygens, and hydrogen atoms and reconfiguring them for useful purposes such as high-density energy fuels, which I think is very possible.
And there was a significant increase in biofuels research in the budget I was looking at earlier, but there was no mention of partnering with the Forest Service or any kind of woody biomass research in there. So I would just encourage you to please take a look at that, and I think that could help us out on multiple levels. Dr. Cordova, quick question for you. In 2013, the President announced the BRAIN Initiative, a multi-agency effort with the important, ambitious goals of better understanding the brain and finding treatments for brain disorders. Last year, the NSF proposed a major ramp-up in funding for understanding the brain research, but nearly flat funding this year. I know in this committee we passed out the READ Act, which has to do with learning disorders, dyslexia, which the research that's there shows that about 90% of learning disorders are associated with dyslexia. And there's been a lot of great research done at Yale on that. But where are we on the brain research and on the funding for the READ Act? For the, I think it was $2.5 million mandated that have to be spent on dyslexia research.
Right, okay, and so on the READ Act, we, as you know, that is enacted in FY17, but we're getting a head start on it. Well, first of all, we have been funding research on disabilities, including dyslexia, for some time. But on the specific act, we're getting a head start by issuing a Dear Colleague letter this year to get the community stimulated to start thinking about writing proposals that we can fund when the act comes into force in FY17. So we're committed to doing that, and as I said, it's been part of the fabric of NSF is to support research on disability for some time. On the brain, NSF has doubled its investments from 2012 to 2016, from $71 million to $147 million. And I think you'd say that is quite a growth. And so we're taking this year, being as a year of budget constraints, to take a pause, assess what have we learned from the brain research that we've been investing in, and where are the new directions where NSF uniquely among all the agencies can then move forward in subsequent years. So we're very, very much committed to the brain, understanding the brain, and this again is an all-directorate effort. We have the social and behavioral sciences engaged, obviously the biological sciences, but also the physicists and engineers are engaged because what we need is better imaging techniques, improved technology.
Thank you.
Thank you, and I now recognize Ms. Bonamici. We're about 10 minutes out from a vote, so we're...
Thank you. Thank you, Madam Chair. I will try to be brief. Welcome back to the committee. First, I want to make a comment and applaud you for your work on STEM research and education as a member of the Education Committee, as well as the Science Committee. It's something that I talk about and work on a regular basis. You mentioned, Dr. Cordova, hands-on learning. That is something that the STEM to STEAM initiative has been involved with integrating arts and design into STEM learning. There are model STEAM schools now across the country, and I happen to have 2 of them in the district I'm honored to represent, and talk about engaged learners. And it is also a benefit because students who are involved in arts and crafts are also going to be more creative and innovative thinkers as they move through their education. And we're seeing more engaged students. So there's a bipartisan STEAM caucus, and I invite colleagues to join us on that. We've seen a lot of progress, and hopefully we'll see a more innovative workforce as well. Dr. Cordova and Dr. Arvizu, is that correct? Last week I met with a constituent who works at Intel. She leads a team in social and behavioral product research, and she talked about how that research is so critical to Intel's ability to develop unique products for different markets and cultural specificity. So I wondered if you could discuss some examples of social and behavioral sciences leading to major breakthroughs. Where has it made a difference? And how is SBE collaborating with other fields of science and engineering? And then I also wanted to ask you about the Geosciences Directorate. As someone who represents a district in Oregon where we have natural hazards like tsunami, earthquakes, landslides, flooding, that's critical research involved in many areas, including but not limited to climate change. So social and behavioral sciences, and also provide us with a few of the budget highlights for the geosciences, please.
Okay, a lot. Okay, first of all, since you started with STEAM, I'll just say that we're committed to any improvement in STEM learning, including its incorporation with the arts. And in our informal STEM program, we do fund projects like Ear Sketch would be a very important one for disabled children, to use the arts to learn more about STEM education. So on SBE, we have lots and lots of examples, and I'd be happy to submit them for the record of how important and relevant that they are. The social and behavioral sciences are part of every cross-disciplinary initiative that we have, and that alone shows their importance to everything we do, because technological change comes along with a lot of questions that we have about how to best utilize that technology and incorporate it. One of my favorite recent examples, it has to do with the measurement and data linkage and integration, that SBE research on the linkage of diverse sources of information is very important to the Department of Defense, which relies on us to help fund. It's the fusion of both hard and soft forms of data, and how, so they want to have the ability to fuse intelligence data with social media, mass media, and behavioral survey data, because they believe it's critical to forming a more comprehensive situational awareness, and we've all seen examples of this worldwide. And that is really a social and behavioral application. Another, of course, is in anything to do with cybersecurity. We all know that at least half, if not 3/4 of the problem, is the social and behavioral response to making us more secure. And the third thing that you asked about has to do with the geosciences. We have there a number of initiatives that are all embraced under the rubric of risk and resilience, and that is how we respond, and again, including the social sciences, how we respond to hurricanes and tornadoes and earthquakes and landslides and any kinds of natural or human-made disasters, that we want to be able to identify risks better. We want to do modeling and simulation of how to respond to them, and we believe that lives can be, we can demonstrate that lives can be saved that way. And then we've made a couple of references, as has Dr. Arvizu, to our Infuse initiative, our innovation at the nexus of food, water, and energy. And this is very much a place where the geosciences has a big role to play, because it's all about the land and and its uses. We had a biomass question here as far as energy is concerned in water, whether it's underground or above ground, and the production of food. And that
I see my time is
applies
expired, so
so
if there's-
much.
if
Yeah,
there's more,
so
please submit it.
There's
Thank you.
lots of examples we'll submit for the
Yeah, no, and my apologies because we are under 5 minutes now for our vote.
Okay.
So if Mr. Tonko could submit his questions for the record.
I will, Chair. I just want to thank our two guests, Dr. Cordova and Dr. Arvizu, for the great advocacy that you have provided for climate change and the geosciences. There are some that would suggest if we ignored it, it'll just go away, but that doesn't happen. So I appreciate the advocacy, and we'll submit some other questions that I had for the record. And thank you.
Thank you.
Madam
And the
Chair.
record will remain open for 2 weeks for additional written questions from members. We did check and they wouldn't hold our votes, so my apology. The hearing is adjourned.
Okay, thank you.